Okay, guys, now calculating the probability. Let's have a look. It says here at the beginning, probability is a single value when x equals little x. Single value. Remember, with the single discrete value, there's no area because it's just single value, x equals 5 or something. It's just a single line, okay? Just a line. There's no area to calculate, so it'll be 0. Okay, that's what it means by this first sentence there. For continuous probability distribution, we can only find the probability of a range of values, okay? So between, like, restricted to like the portion of 2 values, like 0 to 3 or 4 to 5 or something like that. Okay, so that's what it means. Also, since p of x equals a equals 0 and a p of x equals b equals 0, which means when x value is a single value, there's a equal to 0. And with that, it doesn't really matter whether it's included or equal to or not, bigger than or equal to or less than equal to, because it's going to go up to that, area. Basic idea here is really probability equals area. If you could just remember that, that would be really good for this topic. So I'm going to do example 3. Okay, for the probability density function, PDF, find probability is what? X is less than or equal to 2. So it's going to go all the way that part. So that's the shading part. Okay, so that's what it is. Now, I told you the probability is the area. So this looks like area of rectangle, doesn't it? So what's the area of rectangle? Length, okay, just make length times width. Okay, so in here, my length is 2, my width is 1/5. Okay, so how do I write this? Probability x is less than equal to 2 equals 2 times 1/5, 2/5. That's it. How easy is that? Now, with this second one, part B, x is between 1 and 4. Okay, so this is the part we're looking at. Again, it's the area that we're dealing with. It's the length times width. So 3 times 1/5. That's it. That's all. Okay, guys, probabilities in probability density functions, PDF. Now, here it says probability capital X is less than equal to little x. Now, what does that really mean in here? When you look at this diagram and this diagram or these graphs, okay, both of them. So the first one is the probability that capital X is less than that of little x. Area under the curve is on the left side of that number. So left side, so this area is on the left, okay, left hand side of this number x. That's what that means. Okay, so this left is like that. Okay, and here the second one, it's in the probability between 2 values, which is a and b here, 2 values in the a and b here, is area under the curve between 2 values. Okay, between 2 values. So these ones, between 2 values. Okay, so that's what that really means. It's just a common sense. All right. Okay, example 4. A function is given by f of x equals 3x squared all over 117, defined in the domain 2 to 5, 2 and 5, inclusive. Find first one. Okay, so it's basically we have to find the area. So therefore we have to use integration here. So we got domain as a 2 and a 5 here. So what does that mean? Like it's 2 included, 3, 4, 5. 5 included. Okay, but the x is belongs to, it's only this 2, isn't it? No, what am I doing? 2, 3, 4 here. So x is less than equal to 4. So which is 4 is included, 4, 3, 2. But we can't really go any further because it's actually restricted to a portion of a 2 and 5 there in between there. Okay, between 2 and 5. So that's our limits. Okay, that's our limit. So what I'm going to do here now is the area equals, we're going to go 4, 2 to 4, and then writing down the formula, the equation 117 dx, and then I'm going to put the constant out, so x squared dx. So what do we do here now? 107 x cubed over 3, 4 and 2. Now when I put 1 over 3 out, because I just don't want to deal with the constant, 4, 2 cancels out. We got 1 over 117, 4 to the power of 3, take away 2 to the power of 3. And when we do that, we will get 56 over 117th. Okay, so that's what you got. So our domain was 2, 3, 4, 5. And our condition here, 3 to 4. So that's a 3 to 4 here. Okay, so let's have a look. 4, 3, and then I will just write 3x. So I could just do quickly because we know what's it going to be like. So it's going to be 4 to the power of 3 minus 3 to the power of 3. Okay, so I'll just remember that from previous question, that's what's going to happen, isn't it? That's what x cubed, and then there is limits from 3 to 4. The answer is 37 over 117th. Okay, so that's what we got. So I just have to remember, guys, these parts. Okay, so uniform probability distribution, every outcome has the same probability. Okay, so let's just remember that. And then let's have a look at the example 5. A continuous probability function, y equals f of x, is uniform. Okay, so in the domain 5 to 15, so that means they're all the same. Okay, same probability. 5 and 15, they're inclusive. And sketch the probability density function, PDF, and that's what I've got here. And they're all the same, so it's going to be flat. Okay, so that's the x values, it's in a domain, x values. So it's going from 5 to 15. We need to have heights here, isn't it? Oops, that's not really quite height there, so up to here somewhere. So we need to know the heights here. Well, we got the area is 1 here. And if we can find using the formula of the rectangle, length times width equals the area, which is 1. Okay, so therefore, I'm going to just go area equals length times width, or they said here base times height. That's the same thing. Okay, so I know that area is 1. My length is 15 take away 5 times width, which is height. Okay, I know why they use a base and height, because that's considered as a height there. Okay, so that would be 10 h equals 1, h is 1 over 10. So my height here is 1 over 10. So my y value is 1 over 10. If I can just have the whole sketch here, all I need right now for my answer to be perfect, it would be that. Next one we need to do, find probability when x is bigger than or equal to 8. So that means just have to find the area. Okay, just find the area. So we do know that from the previous part, we got 5 to 15, 5, 15 here, but there's a new condition. New condition applies there. X is bigger than or equal to 8. So anything above up to 15 is what is involved. So that's what we have to find. Okay, we got the height, 1 over 10th. So that's okay. So how are we going to do that? Easy. 15 take away 8, isn't it? So let's have a look. P x is bigger than or equal to 8 equals base times height. My base is 15 take away 8 times the height, 1 over 10th. Okay, so that's going to be 7 over 10. Okay, so that's a 7. I want you to have a look at, because it's coming up, so I want you to have a look pattern here. Okay, so that's a 7. So our, the length, and that's end up with a 7. And the previous one, this part is 10, right? This is 10. And we end up with 10 here. Okay? There's something is happening. Okay, another thing here. Let's have a look. So this time is 7 to 10. So not all the way to 15, but it's in between. 7 to 10. So even that 7 to 10, okay? So we do 10 minus 7. So the length is 3 here. Can we predict something? The answer. Because the second part, it was whatever the gap here over 10. So it will be 3 over 10, wouldn't it? Because we are looking for area. And then my base is 3. So base times height, which is 1 over 10, it will be. So let's have a look at that. 7 x 10 equals, my base is 10 minus 7, and my height is 1 over 10th. So that will become 3 times 10. Obviously, 3 over 10. Okay, so you're probably starting to get the pattern of this. So remember, it doesn't really matter whether it's a bigger or less, or bigger than equal to, less than equal to. It's all going to be the same. So if it was in between 8 and 11, 11 and 8, the gap is a 3. So I'm predicting 3 over 10. Okay, so P equals 11 minus 8 times 1/10, 3 over 10, because the diagram was like this. Okay guys, it also sums up nicely now. What does that really mean? Uniform continuous probability distributions. F of x is 1 over b over a for x is between a and b, and it's 0 for all the other x values. Now this is what we've done the first one of the examples. We've done, like, it was a 5 here, and that was a 15 here, and then between was 10. So, and then the height was 10. Okay, something like that. Now, what is it this means? Equal intervals along the x-axis will have the same probability, which means the same area. Okay, so this is the same area. When they're talking about probability here, we're talking about area. So what does that mean? Equal intervals along the x-axis. So for example, say 1 to 3. Okay, so we got same area of the rectangle 1 to 3. So say it's got the same height, going say 1/10. And that's a 3, 1, 2, 3, so it's a 2 there. It will be the same as if I draw 7, 9. Okay, so that's still 2, isn't it? So equal intervals, equal width, or if you like, equal base, okay, along the x-axis. Now this is x-axis. Will have the same probability because that probability, that area is same as this area. Okay, area 1 is area 2 because they got the same intervals, because they got the same width. That's what that means. Okay? And same thing as before, the intervals with the same width have the same probability. It just means that they got the same area. That's all for now. See ya.